Hi, good evening, friends. Today is Sunday, and let's try to solve one problem from the Gigs for Gigs of the POTD. So, today we have this problem is to finding the closest neighbor in the VST binary search tree. Okay, so if you don't know the data structure of the tree, then first understand the data structure of tree and then solve this problem. So you have plenty of time. Okay, 6 hours 12 minutes and 48 seconds still you have. So we'll start the solving. So it's a easy type question. We have to find the closest neighbor in BST. If you are able to solve this and pass all the test case, you'll get the 2 points. So here you will have a node as the five, and then left and the right node you're still having. Okay. So what the question is saying is that you will have a VST and a number. You have to find the greatest number in the binary search tree that is less than or equal to n. So they will give one integer n, and then we have to find the nearest. Suppose here the value of the n is 24. So what is the nearest of 24 is the 21 because 25 is again larger. So 21 is the nearest. So this is how we will find it. Again, if the n is 4, then you have to return the 3. Okay, the 3 like this. So it's very simple. It's a easy straight question. So what we can do is, do they give anything like returning of -1 or something? Yeah. If you are not finding any of the elements in the VST, then you have to return the -1. Expected time complexity is 0. Sorry, big O of height of the BST and auxiliary also big O of height of the BST. Okay. Oh my. Okay. So my approach is very simple. First, I will declare one result so that if I don't get the value also I'll return -1. Okay. Otherwise, I will update this result value and I will return the result value. All right. So first, what we can do is I will traverse the VST unless and until the root is not empty. We have to do some operation. How they give the template? Okay, they use the key, not the data. Okay, fine. So we have to look this also. Now, question states that suppose if your root dot key, what they say, firstly, if it is greater than the root, that we have to go in the right hand side. That is your right side. If it is lower than, you have to go on the left hand side. See here, 24. 24 is greater than the root, so it's come in the right side. So it's going on the right side. Even though the result is 21, we go on the right side. Here it is 3. It is smaller than the root, so we know that it will go on the left side. Okay. So why is not working? Okay. So it is not equal to. It is lesser than or equal to n. Then what we can do is we'll first get the result. We'll call the result. In the result, what I will put is I will put the dot, this root dot key. I will put it, and then in the root, I will reassign the value of the result. No, no, wait. Here the root is empty. Fine, result is here. Okay. In the root, I will traverse the right hand side. Root dot right. Okay, this is nothing. This is just traversing the right hand side. If this is not the case, then what we will do in the root place, we'll return the root dot left. So that's how we'll do. And finally, we'll just return the result. Okay, first let me just check one time. Yes, yes, okay. So see here, I'll just explain my code here. So the root is 5 here, right? So the root is what? 5. So the root is 5, and then is it greater than, lesser than or equal to the n? So what's the value of the n? N is now 24, right? N is 24. So if this is a condition, then what we will do, in place of the result was -1 before, so we don't, so it was -1 before, and in place of -1, what I will assign is root dot key. What is root dot key? That is a root, your 5. 5 will be now assigned instead of this -1, we are reassigning with the 5. Okay. And in place of the root, what you're assigning, root dot right, because this is n is greater than the root. So we'll go on the right hand side. Okay. So now it will come here and it will go to 12. Okay. So 12. Now it's 12. Your root value is 12. Again, now the 12 will come here is 12. No, firstly it will come here. Root has some value, right? Root has some value. So root is not null. So now it will come here. So your root dot key, when we get the root dot key, you will get 12. So 12 is again lesser than or equal to 24. This is okay. So again, it will go to right. Now it's 21, right? So 21 in the root again, we replace with the 21. Am I right? No, root dot right is 21, but what here is 12. In place of the result, root dot key. No, this is 12. Okay, this is 12. Root dot key is 12. Okay, now we are assigning to the result root dot key, and now in the root, I'm going to the right hand side. So now it will go with 21. Okay, so this root is becoming now 21. So it will go again here. So this is some value 21. So root has some value. Now it's again not null. So it will come back to here 21. 21 is again lesser than or equal to 24. This is also correct. So now it will come, it will rearrange to 21. Now I will go to here 25, right? 25. So again it will come back here 25. So it will ask now, this 25 is lesser than or equal to 24. No, this is not true. This condition is not true. So we will return the result. So what is the result here? 21. Okay, so it will return 21. Otherwise, it will directly do the vice versa. That's why we said the else part. Okay, so we'll go to the else part. Okay, in the result, see this 21 will be returned here because result is now 21, not -1. Okay, now this is 21. So like this, it will do. I'll submit it. Let's check. Okay, fine. See, there is a good thing is there. If you do if you do continuously, gigs for gigs for like 8 days continuously, they will give you another bonus 8 gig for gigs bits. Okay, so this is a good thing. So continue. Don't skip the PODT of the day. Okay, try to maintain the rhythm. Okay.